Hello students, welcome to the interesting chemistry where you'll find a feeling of classroom teaching, and you can also enjoy a classroom teaching from your study room by watching the video of the interesting chemistry. So in continuance of the redox reactions, I have told you and explained you about the oxidation and reduction, the electronic concept of the oxidation reduction, oxidation number, the concept of the oxidation number and calculation of the oxidation number, and last I also explained how will you balance the ionic equation of the redox reactions by two methods, oxidation number method and the ion electron method. In the last today I am going to explain you the formal charge. What is formal charge? This dictate on FC or the formal charge. To explain the formal charge, I have to discuss with you all the three types of bonding: ionic bonding, covalent bonding and coordinate bonding. In ionic bonding, it is Na positive and Cl negative. It is total transfer of electron. It's a transfer of electrons. And here in this hydrogen and hydrogen, it is sharing of electrons. Sharing of electrons. In ionic it is a complete transfer, it is a sharing, but when the atoms are of different electronegativity, then this electron pair will shift towards this. You can also in this way, this is hydrogen, delta positive and delta negative. A partial charge occurs on the atoms, the hydrogen delta positive and chlorine delta negative. It's a partial. It is due to this shift. This electron pair is shifted towards the chlorine. That's why the electron density also shifts towards the chlorine. So the electron density on the chlorine atom will be greater than hydrogen, and so there will be a delta negative and delta positive charge. This is a covalent bond. But in coordinate bond, coordinate bonding, what? Suppose this A is electron rich and this B is electron deficient, or have the capacity to accept the electron. Electron deficient means it has the capacity to accept some electrons. So it is electron deficient, and we told you like this, that A donate one electron to B and then it combined with A and B to form the bonding A and B. These both electrons are of A, but now as B is bonded with A, so B also have some right on this electron pair. So here A and B are bonded, but to show the bond like a covalent bond, it doesn't tell us that who is the donor and who is the receptor here. So this you will show this bond in this way. This shows that A donates to electron, one electron to B, then they bonded with each other. Then they form a bond with each other. You can again, this will, here you will find like this. This is negative and this is positive. This is negative and this positive and negative is a formal charge that is found in the coordinate compounds. They found in the coordinate compound. It is totally different from this. It's a complete transfer of electrons. It is a shifting of electrons. This is again, and now it is a transfer, but not a complete transfer. It is a partial transfer. So P is partial transfer of electron, transfer of electrons, partial transfer. The charge is occurred due to the partial transfer of electron. That charge is called as formal charge, or the Fc. So I have explained how will you tell the formal charge or Fc in the coordinate compound. Now I am giving a typical example for this to explain. How will you explain in your exam what is the formal charge? So with the bonding you can tell, but the example is here that this is ammonia. This is ammonia and ammonia, and this nitrogen has a lone pair of electrons. This nitrogen has a lone pair of electrons, and again here this is BF3. It is BF3, boron. So this boron atom is an electron deficient. It has not complete octet, 2, 2 and 2. Only 6 electrons are there. It didn't complete its octets. So it is unstable. When the boron will come in the contact of the nitrogen will give him the electron. So it is a partial transfer, because this electron is partial again. They will bonded with each other. This is each other. MS3, and like this is the coordinate bond, and now you can write here S3 and BF3. Here you will write negative here on the nitrogen. This type of the charge that occurs due to the partial transfer of the electron, that is called the formal charge. Now question arises, how will you calculate, or how will you find the formal charge? So again I am giving it trick. Whenever you find a coordinate bond like this, so you can write here in this way. This is positive. So A has the positive charge and one positive. So one formal charge plus one formal charge, and B has minus one formal charge. But I will tell you how will you find the formal charge in this way. So here I have given the question. First question here. What is that? Find out the oxidation number and formal charge for Fc formal charge of the underlined atoms. These are the CsClO4, the Cl, and S3PO4 in this phosphorus. Oxidation number. Find out the oxidation number. So now I am here. It's my duty to tell you that the oxidation number and formal charge both are different, totally different with each other. They are not similar. Because when suppose you calculate the oxidation number of Cl, hydrogen is +1. As I explained in my previous video, how to calculate the oxidation number. So here Cl is equal to X plus 4 into minus 2 is equal to 0. So the ON of chlorine is chlorine X is equal to X minus 8 plus 1 minus 7 is equal to plus 7. So here the oxidation number of chlorine is plus 7. And now calculate the formal charge. How will you find the formal charge? How will you calculate the formal charge? I have written the formula to find the formal charge. This is the formula. Fc, same formal charge, is equal to number of electrons in the valency shell. Number of electrons in the valency shell. Suppose you want to find out the formal charge of chlorine in SClO4. So here you will write here Cl is equal to the Fc of Cl is equal to number of electrons in the valency shell. So chlorine is here. Chlorine, the atomic number of chlorine is 17. So 287. So there are 7 electrons in the valency shell of the chlorine. So we will write here 7. You will write here 7 minus number of bonds which are formed by chlorine. This chlorine, how many bonds are there in SClO4 around chlorine? You should know. So here, to find out the formal charge, you should know about the Lewis structure of the compound. So we write here H SClO4 O Cl, and this is the structure of SClO4. So without knowing this structure, Lewis structure of the compound, you cannot find the formal charge. So know about the Lewis structure, then you will be able to calculate the formal charge. So here again I am telling you the Fc of the Cl. Here the number of electrons in the valency shell is 7, and now number of bonds around, there are 4 bonds, 1, 2, 3 and 4. So here you can write here 4. You can write here 4 plus, then here plus number of electrons that not taking part in bonding. So is there any electron around chlorine that haven't taken part in the bonding? There are 7 electrons, so 2 electrons had donated here, 2 electrons here, 2 electrons here, and this one, to 2 and 6 plus 1. So this one will be 0. Here, okay, 7 minus 4 is equal to, you can write the formal charge is 3. So in this structure, the formal charge of chlorine is plus 3, and the oxidation number is 7 plus 7. So oxidation number and Fc both are different things. Never confused about that the Fc and the oxidation number are the similar thing. No, both are different. So I have told you with the examples here. Again, my last thing, I am telling you, there are 3 coordinate bonds. You can write here minus, minus, minus. There are 3 minus. So here there are 3 plus here. So because chlorine has 3 coordinate bonds. And you can write here in this way, this O chlorine, and this O negative, negative, negative. So here 3 negative, 3 positive. 3 I have written 3 positive. Yes, here 3, because 3 are negative. You can calculate it directly. Relate to this calculation. This formula of the calculation is this, and you can get to know about direct method that these are the coordinate bond, and D can be represented by minus and plus, minus and plus, minus and plus. So the formal charge of chlorine here is plus 3. So I have explained this one SClO4, and now I will tell you about the structure phosphorus. Calculate the oxidation number. So here there are 3 hydrogen, 3 plus phosphorus X plus 4 into minus 2 is equal to 0. So X is equal to minus 8 plus 3. So here 5. The oxidation number of phosphorus is 5. I am telling you oxygen. But what will be the formal charge of? What will be the formal charge of this phosphorus in this structure? So as I told you, as I explained in the previous example, that without knowing the Lewis structure of the compound, you can't find the formal charge. So write here structure S3PO4. This is S3PO. S3PO. This is S3PO. Is there any coordinate bond around the phosphorus? There is no coordinate. So you can say directly, you can say that the formal charge of phosphorus is 0. You can say directly, so there is no coordinate bond. Coordinate bond, there is no coordinate. So you can, but you can calculate the FC of P is equal to number of electrons in the valency shell of phosphorus. So the atomic number of phosphorus is 15. So you can write 2, 8 and 5. So here there are 5 electrons in the outermost orbit, the number of electrons in the valency shell. Number of bonds here 2, 3 into 2, 3 and plus 2, 5. Is there any electron around phosphorus that have not taken part in the bonding? No. Because there is no, that all the electrons have been utilized in forming the bond. So here you can write 0. So the formal charge of the phosphorus in this compound is 0. So the formula. In this way, you can calculate, you can find the formal charge of any atom in any compound. Now I am coming to the question number 2. Prove that HNO3 is a molecule and SiF6 is an ion. How will you prove that HNO3 is a molecule? And you know the molecule, always the molecule is a neutral. Molecule is a neutral. So if the all formal charge of the each atoms found in HNO3 is 0, then HNO3 is molecule. How do you? So first of all, write the structure, Lewis structure of HNO. This is HNO3. This is HNO3. Now I will calculate the formal charge of each atoms that are found in the HNO3, hydrogen, oxygen, and nitrogen. First of all, I am coming to the nitrogen. The FC of N is equal to number of electrons in the valency shell, nitrogen 7 and 7 to 5. So here you can write here 5 plus number of bonds 1, 2, 4 minus 4. Number of bond 4, and the number of electrons that not taking part in the bonding. So there is no electron, any electron so that they haven't taken part in the bonding. So you can write here plus 0. So the formal charge of nitrogen is plus 1. You can calculate. This is the bond. So here plus 1 and here plus 1. But you have to write it this way. You can get to know. You can know from this. You can write here plus 1 and minus 1. So the formal charge of nitrogen is plus 1. But you have to know I am going to find or calculate the formal charge of each atoms found in HNO3. Now come to the hydrogen, Fc hydrogen. The Fc of hydrogen is 1 number of electrons in the valency shell minus bond 1 plus 0. And so it is 0. The formal charge of hydrogen in HNO3 is 0. Now this oxygen is alpha. So Fc of the O alpha is equal to this alpha hydrogen oxygen. There are 6 electrons. So all these electrons I can complete here. There are 4 electrons, 1 electron taking part in the bonding with nitrogen, and 1 electron have taken part in the bonding with the hydrogen. So 2 electrons have utilized in the bonding, and 4 electrons are remain that are unbonded and they have taken part in the bonding. So you can write here O alpha. There are 6 electrons in the valency shell minus there are 2 bonds plus there are 4 electrons that have taken part in the. So here O alpha is 0. The formal charge on Fc or formal charge on alpha oxygen is 0. Now come to suppose this is beta oxygen. This is beta 2 oxygen. 2 electrons have taken part in bonding. So here total 6 electrons and 2 have taken part here. So the O beta is equal to 6 minus bonding 2 plus 4. Here is again 0. This O beta is 0 and this O it should be minus 1. Because you know that this is plus 1 and this is 1. So here also the answer will be our minus 1. How will you find the answer? So write here O gamma. This one O gamma. Now complete the electron. This is this electron. So in this bonding, the electron of the oxygen hasn't taken part. It is nitrogen that gave the 1 electron to oxygen and again make a bond with the oxygen. So here you can write here in this way 6, the number of electrons in the valency shell minus and bonding 1. Here only 1 bond plus the electrons that haven't taken part in the bonding or the number of electrons that have not taken part in the bonding. So here 6 electrons. You can write here 6 electrons. So here 6 minus 6, 7 is equal to minus 1. Now total find the total of the formal charge of all atoms that are found in HNO3. That is 0. That is 0. So HNO3 is a molecule. So HNO3 is a molecule. Now come to the SiF6. This is the structure of SiF6. This is SiF6. SiF6. Fluorine, this X. fluorine has 7 electrons in his outermost orbital of the valency cell, and 1 electron had utilized in the bonding. So this is the account of the 7 electrons of the fluorine. Now count the Fc of Si is equal to the atomic number of silicon is 14, so 2, 8 and 4. So here the number of electrons that are found in the valency cell is 4. And again minus, it is minus, and number of bonds, there are 6 bonds around silica. So you write here 6 plus 6 plus number of electrons that haven't taken part in the bonding, nil, 0. So here the formal charge on Si is -2. There is no any covalent bond. Here you can't, how will you know? When there is a covalent bond, that you can find positive and negative formal charge. But here, in a case of SiF6, there is no covalent bond. So here -2. Again, come to the fluorine is Fc of fluorine. The number of electrons in the valency cell of the fluorine is 7 minus number of bonds 1 plus number of electrons that not taken part in the bonding is 6. And 6 plus 7, so it is 0. It is 0. Each fluorine has 6. And here 6. In this case, you can write. So all the fluorines have the formal charge 0. You can multiply this by 6. So it is 0. Now the formal charge of the all atoms that are found in SiF6. So here -2. Here -2. So you will write here SiF6 is an ion. SiF6 is an ion. To decide whether a structure is a molecule or an ion, the formal charge is very important to decide that between the molecule and ion. That's all for today. I hope that this video is very useful for you, and you should watch my video from start to end. And please share to your friends. That's why they can also get some benefit from this video. I hope that you will like it, share it. That's all for today. Thank you very much.